So this is more of an update. You could almost bring this up, you know, sort of a mini community thing. Can everyone hear me okay? All right, this is completely impromptu. So I apologize and feel free to just throw popcorn and I'll get off stage. Kubernetes is now hitting the point where people often say a lot of the 80% of the building is done. And what we're doing now is all of the hard problems that we sort of left behind. The magic of Kubernetes is that you often don't have to think about many pieces it handles for you. So auto healing and sizing and dynamically just growing to be as big as your application sees fit. You know, that's sort of the promise of Kubernetes. And if you have infinite resources or you have an application that is much smaller than the footprint of your cluster or how big your cluster can grow, or much smaller of all your pods will fit nice and neatly into the node, it works really well. There are 2 or 3 things going on right now that are working against that and making that harder as time goes on. So one of the first ones I'll bring up is the term add-ons. The term, I think, is used and bandied about pretty loosely inside of Kubernetes. As far as I can understand it, it has 3 meanings. And if anyone has a 4th or disputes one of these, I'm very open to that. And I'd love to make this more of a discussion than just me getting up here and speaking. So please feel free to chip in. One definition of add-on that I've heard of is a container that runs on the node that is used to, you know, maybe add extra functionality or, you know, keep the system running. So kubedns, I believe, was the original add-on that was put into Kubernetes first when the term was used formally. You know, it isn't really needed for Kubernetes to survive or exist, but man, it makes things a lot easier and has now become an expected part of the system. Another use of the term add-on is items of functionality that may be on the master or spread throughout the cluster. So if you take a look at Calico, some people refer to that as an add-on also, where Tigera's Calico implements network policy. Network policy is another set of functionality that you run first on the master, and then also to have it scale, it involves 2 tiered levels of deployments inside of your cluster. One that lives on every node and deals with IP table management, and then another set of vertical auto-scaling proxies that distribute logic throughout the system. And then the last one, or the last use of the term that I've heard, is an add-on could be a larger level of functionality that really, really sits on top of Kubernetes as opposed to inside or even per node. So is anyone here, out of curiosity, familiar with the service catalog? So I see a few hands. Istio, have you folks heard of that? So the service catalog, if you can think about it, is like a big menu of services that your Kubernetes cluster can interact with or install into the cluster. And it really does sit inside of Kubernetes and is hosted on top of it. And I've often heard that referred to as another add-on. Regardless of what level of add-ons we're discussing, each one of them ends up consuming resources in the system. And these resources in the system are right now, as we discussed earlier, been sort of considered to be an infinite resource to some degree. And they sort of have, let's say on the node, to take a first look at it, several areas that we all need to be aware of, especially the SIG, in my opinion, because this SIG's functionality crosses into each one of these areas. So when you have a file system and you're mounting it, file systems take up RAM footprint and they take up disk footprint also. And that footprint is generally not considered part of the cost of a container. So just mounting the host's OS file system, you're incurring some cost to the system. And let's say you have a host disk that's 2 gigabytes versus one that's, you know, 200 terabytes. The amount of RAM that's being consumed is going to differ. Where does that get accounted? And how does the system actually factor that into what is consumed, or are our customers also aware of that? Because this is sort of a price that it's just cut off the top. It's a tax that you really can't affect that much. It's just sort of a base piece of the system before the first Kubernetes executable is even run. The kubelet also is not something that you can have a node being functional without at this point. The kubelet, anyone know offhand the latest footprint of a kubelet today? Let's take a guess. How many people think it's smaller than a 250 megabytes? Bigger than 250 megabytes. Bigger than 500 megabytes. Bigger than a gigabyte. So I think the last number that I saw was it's 700 megabytes. that's a pretty big piece out of your memory resource footprint. And especially if you're like in a cloud sector, a cloud host provider, or you're charging by the resource footprint that the user has. And again, we haven't even started with the cost of your application. On top of that, you have a complicated world of other add-ons that are being added by the community all the time. So when folks are adding code today, we don't really have a system inside of the open source Kubernetes world that is, keeping track of how much resources are being consumed of every new release. Just like Brad was talking about earlier, the fact that we're not tracking like the performance impact of the development that we're doing, we're also not tracking the footprint either over time. And my bet is that the kubelet probably was not 3/4 of a gigabyte in Kubernetes 1.0. That's just my guess. Brad's nodding yes. Saad is, also looking like he agrees. So I don't know about you, but if you don't measure cost, it tends to just metastasize over and over and over again. And this is something I think the community is going to be wrestling with as time goes on. So there's a lot of other pieces here that are happening. The other one is a question that came up is, yeah, sure.
So we talked about when you were defining add-on. There's a running joke in my company that there's two things when you deploy a Kubernetes cluster. The Kubernetes cluster that can't do anything. There's one which actually is useful.
Right. So,
and like for example, like services in Kubernetes, they're a core Kubernetes object. But you can't have one service discover another unless an add-on is present.
So the comment is that there's two types of Kubernetes clusters, those with add-ons and those without, and only one of them is useful. And this is a running gag. Yeah, it is. It's definitely a good point. It's kind of like when you go to the car dealer and they say the car is only $20,000, but oh, you want wheels, and then we'll start raising the price. So
the question was more of like, do we want to go towards a thought process where like an add-on is so necessary and useful that it should be part of core?
So this is where things get interesting. The term add-on, I feel, is insufficient because what you think is like the way you described add-on was it's core, or it's something that's a required piece for at least the deployment of the cluster that you've got. But so things like service catalog or maybe Istio for other people aren't core at all. They have a much bigger footprint. So
the definition I had is that if you want to support a core Kubernetes object, for that what is required should be in the cluster.
Sure, but what you think is a core Kubernetes object, other people don't. So there's an opinion there too. So the comment was, because he's not on the mic, is what is the stripped down most basic piece of what Kubernetes needs to be, and what's the footprint look like there? And it gets even more complicated. So even if you, let's say, have all of the containers deployed in order to have some basic amount of functionality, the scale that you employ inside the system also incurs interesting side effects. So the one I like to bring up a lot is Heapster. Is everyone here familiar with Heapster? Okay, so Heapster balloons when your load changes. And what we have found a lot is that we will often have Heapster and fall over, in which case HPA stops working, monitoring stops working, your dashboards turn off. If you put in, let's say, too many pods per node, or maybe even too many pods per cluster. And so being able to size these applications and understand which ones need to be guaranteed versus best effort versus burstable becomes more interesting. The main reason I'm trying to bring this up here is to let you also know about two pieces of technology. One of them, I think Lewis was asking about yesterday, was, how do we know which ones are required or which ones aren't? There's a feature called Node Allocatable, which has been deployed in open source, in 1.5, I think, or 1.6. It's been out there for a while for CPU and RAM, and we're extending the scope of it to storage also. Jing, are you doing that in 1.9? Oh, it's already in 1.7? Okay, great. And what this does is, this is a way of reserving resources for the system to say that, when you are scheduling your pods, they are going to assume that these resources are not going to be available for your application to consume. This has already been there in truth, but now it's a drawn line that's much more clear. The downside is how we've sized it was a little bit like this, testing the wind and based on experience. And so there's a base number for every single node, and then there's a percentage that gets added based on the size of the node for how big this reserve is. And it's, if you end up not needing all of that reserve, well, you've got some fragmented stranded resources. And if you need to use more than that reserve, well, it's not like the system is not going to allow you to allocate that reserve to create your node and to operate your node. But what it does do is it puts a limit on exactly what's being allocated to the pods. It took me a long time to wrap my head around it, and I urge you, please look it up, the details there, because it's something that I think is important enough to anybody who is managing services on the node, especially us, where we're adding new infrastructure pieces to this workflow. The other item that I think is interesting is the idea that the KubeSys, for me, what was really interesting, I don't know if OpenShift has this, but in GKE, there's a dashboard where you can go and see all the containers that are being deployed on your system. And then it automatically filters out the KubeSys namespace. But if you turn off that filter, you can see all of these other containers and pods that are running that are in the KubeSys namespace. And these are generally systems that are considered requirement for the system of Kubernetes. And those are the ones that you can generally fall within the category of what's required. And if you feel that you are adding something to the system that needs to be existent for Kubernetes everywhere for everyone, that is generally where it's accounted. It's hard to get inside of KubeSys, which it normally should be. I think that goes through the node SIG, and they're generally on top of what they think takes a node to define a node and node functionality. That's really all I've got. I don't know if people have questions. We have some open questions, I think, going forward for Kubernetes. At Google, we have a system called the SIS container. It's the smallest possible footprint of CPU, RAM, and disk because it exists on every machine inside of Google's data centers. So arguably, if you raise that limit, let's say by 5 megabytes, you are incurring trillions and billions of dollars, like half of Saad's weekly payroll for the entire company. And this is why it's carefully watched. And at Google, I think there's like 3 engineers who all have to unanimously agree before this SIS container is resized. And it's something that is watched very, very closely. In Kubernetes, I don't think we have anything like this right now. And I believe that it's going to become an increasing problem. What happens when the base footprint of a node is 1.5 gigs? It's probably going to not work on a Raspberry Pi or many of the other environments that we want it to run on. And Go, in my mind, is not always the most compact representation. And we also have a model in Kubernetes that is about just create another container or create another Go code program or create another pod. And I don't know how much longer that pattern is going to continue because it's an expensive one for resources. So I don't know, Steve, you've got the mic.
Yeah, I just, this makes me harken back to a conversation at KubeCon last year about, having minimalistic node footprints, but being able to advertise everything that they have down to like the kernel version, and then basically applications specifying their dependencies and then being able to pull those down and load them with the application or start them with the application on the node they get scheduled on. Wouldn't that approach allow us to keep a fairly minimalistic node footprint and then let stuff that the applications need that are sort of like host type things get pulled down with the application on demand?
So we talked about this before about the fact that a lot of the mount plugins have such a large dependency on OS and tools. And I look at the work that Jans has been doing, and I think that really fulfills a lot of the functional dependencies there, so that hopefully we're less dependent on the OS and we can bring in a lot of that functionality. You'll still be dependent on the kernel and kernel flags to some degree. None of those plans that at least people were talking about back then, I think Brad was the one who really just yanked me around at KubeCon and said, Rubin, think about these dependencies. It's harder than you think. None of them really address the footprint issue, because I think it's very hard to quantify if you're going to add, let's just say, XFS support inside of the kernel, what the memory footprint is for that. And also, these things are so dynamic. So to me, I'm less concerned really with the kernel footprints overall, and I'm more interested in what we're doing with Kubernetes, what both containers and pod functionality we're requiring. I'm really curious about how big CSI gets and how big that infrastructure is going to be. And I'm also curious about what other pieces we allow things in at scale. So when you look at the scale testing and you do like 5,000 nodes or how many pods that you have on a node, the shape of the machine really, really, really changes, surprisingly so. And that's where I'm really curious, again, for anybody here who's been running, let's say, over 35 or over 50 pods on a machine, what that ends up doing. Even if the pods are small, the kubelet has to suddenly start, its behavior changes and its footprint changes. So I'm less worried about the kernel right now, because the kernel is kind of designed to be pretty lean overall. The one exception to that I've seen, like I've said, is when you have large gradations in the capacity of the drive. Because there are certain kernel data structures that all have to be loaded into RAM at one time, like inodes or superblocks or things of that nature. But in general, the kernel is, it's meant to operate in these smaller environments. I don't think Kubernetes really is. I don't think of Go. I'm not sure Go is either, especially with garbage collection. And this is all intuitive based and not a lot of measurements, except we know we've seen a lot of problems here.
So it's not so much like the host specific stuff. It's like all these add-ons.
Yes.
That sort of we don't necessarily ship with Kube, but kind of are needed in a lot of the main scenarios. And then that creates resource consumption.
Right. Like what happens if you have CSI managed in a pod and you schedule it and it starts pending? What happens when you have a really smart customer who knows exactly how many resources to have on their machine, and so their application takes up just right to the last byte, and then you upgrade the machine's Kubernetes, and then suddenly it's too small. There's not enough space for that pod to schedule, and then none of the pods schedule on any of the machines, because Kubernetes has now taken up another 10 megabytes or so.
Well, could we create like either a config map that has a minimal, entry into each one of these so that that's maintained somewhere? I mean, that's not going to help really if you scale it up and it consumes more than that. But I mean, shouldn't each one of these have some sort of prereq of how much it's going to take up and profiled accordingly? That's
a great idea. And I think both understanding the expectations and coming up with a programmatic way to standardize what they are, I think that's what you're saying. Yeah, that's great. And so I think that's a good suggestion. If you want to bottle that up, send that to Tim, because I know he's thinking about this quite a bit. Sounds cool to me. But in general, I don't think it's something that we're thinking about that much. And I know it's beginning to impact at least some of us and some of our customers, and I expect to impact more. So that's all. It's more of an update. And by the way, node allocatable is also another tool that we can use to at least guarantee that some of the base resources will always be taken care of.
So networking is a little different than storage in the sense that we are able to plumb TCP stacks into pods and let the pod runners or the developers worry about how much of the node resources they're using. We have an option of adding stuff so that storage is treated the same way as in a block device or a file system is charged to the container by adding features.
Are you referring to the TCP window size when you mean the TCP stacks?
No, just like when we plumb an interface into a container, it's not there on the host anymore. It's container to packet going out. And so we're using the same amount of resources, but now it's charged to the pods. And I was wondering if an option would be to say, let's charge storage related things also to the pods so that it doesn't count as a system resource. And it's now visible to the rest of the system.
So I think for some of the initial file system metadata, I don't know if the kernel has facilities to do that. I know it didn't like 7 years ago. I don't know if it does now.
So
and on top of that, I don't know how write back works in these areas. So I'm not sure exactly what the write back tag charging is for C groups. The memory subsystem of Linux, as I understand it at least, it's a pretty much of a, I'll borrow from Peter to pay Paul, or I'll borrow from Sally to pay Alice. And so it's not always clear exactly whose memory is really being allocated right now, and the tracking can get more complicated, which is a really big way of me saying I'm not really sure. But yeah, it's a good idea. But yeah, the config map idea is a good idea too. It's not one I've heard of before. But the good news is, though, if you're starting to try to figure out, what are going to be the requirements on your system and which one of these pods is useful as an add-on or an application versus which ones we think are really, really essential, we do have tools for that. And so again, SIG is a good place to talk to folks there about what we've got. That's really all I got. Was that helpful? Okay, thanks.